Let's look at another way to organize and display some data. Here's a set of grades from the first test of a statistics class. There's a really nice way to display this that actually preserves all of the numerical values and gives you the shape. It's called a stem and leaf plot. So we begin by writing the stems for the data. So we'll start with the lowest number, which is 2, and go to the highest value of 9. So we will normally begin by drawing a vertical line, and we'll begin writing the values. So we're going to start with 2, and then 3, 4, and these are called the stems. In this case, the stem is the tens place of the number. The leaves will go on the other side. So the leaves here are going to be the ones place. So we look here to see where a 2 shows up. So there's a 0. So this is 20. And then we have a 30. So it's going to be a 0. Look at your 40s. So we have a 41. And sometimes I'll go ahead and cross those off so I don't have to look at them again. I've got a 41 and a 45. So I'll put 1, 5. So this is read 41 and 45. And then go to the 50s, and let's cross those two off. I've got a 57, a 52. And now let's look at the 6s. So I've got a 60, 65, 66, and so on. And we'll finish it out like that. So notice here we had 2 values of 88, right? Have an 88 here and an 88 here. And 2 values here, we have an 88 and another 88. Okay, so it's often good to provide some sort of legend here where you say 2 slash 0 is 20. Particularly when these can get a little complicated, when the stems end up being more than just one digit, just the tens. And we'll talk about that here in a moment. Notice that we write the leaves in order. Sometimes the way I create these is I'll go ahead and create them and not worry about the order until the end. So I'll actually have 2 stem and leaf plots. I'll have one where these numbers are out of order. I'll just write them as I see them and I'll sort of fill them in. Sometimes not as tedious that way. Sort of depends on how large the data set is when I'm doing these. So if the data set gets a little large, or even if it's small and it has odd sort of splits, it's common to split the stem and leaf plot up a little bit. So that is, so we split the rows into 2 halves. So leaves from 0 to 4 go in the first half and 5 to 9 in the second half. So here is the output from a statistical software package called StatCrunch. And you notice they've split this up to where, for instance, 41 and 45 are actually in 2 separate pieces here. And similar for all of them are sort of split up into an upper half and a lower half. Notice the shape is still preserved. We still get a sense for this being a kind of a left skewed graph. And this may be easier to see if we actually rotate this 90 degrees. Rotate it 90 degrees. There we go. So we can kind of see this is a left skewed graph here. So with the general shape starting out skinny on the left and then kind of going up and then going back down. In fact, let's go ahead and see the dot plot and stem and leaf plot compared side by side. And here they are. And so we've already seen dot plot. Very similar. The dot plot can be a little trickier to create by hand. So if I walk into my class, I can quickly put this on the whiteboard. I can put the stem and leaf plot on the whiteboard. The dot plot I would have to kind of go ahead and do ahead of time with a software package. And let's go ahead and see this just stacked on top of each other so you can see how these align and how these compare. We see the data value of 20. It's pretty easy to see. And on the dot plot and look down at the stem and leaf plot and we can see 20. And so we can really see quickly that with the stem and leaf plot, all the individual values are preserved. It's a little harder to tell on the dot plot. Often we don't really need the individual values. We just want to get a general sense of the shape of the distribution. So we have some pros and cons with any of these displays, and the stem and leaf plot is no different. So the pros for the stem and leaf plot, as we mentioned, you can create by hand without using software, and it's pretty easy for small data sets. It preserves all the data values, which can be really nice. You can see, like, if you made an 85 on a test, you can see that in the stem and leaf plot very easily, and you can see how you compare to other people who took the test. And you can also easily see the shape of the distribution. There are some cons though. So it keeps all the data. Now I know we said that was a pro. We saw all the data, but with large data sets, imagine a data set has 1,000 values. Those numbers, those leaves would just keep going off the screen or off the page. So with large data sets, this is not very useful. Even with a software package that can create this, it just gets a little tough to decipher. And it can be a challenge to create with large data sets. Or if we have complicated rounding or truncating, the numbers aren't really nice. I gave you a pretty nice data set. It was just numbers like 85 and 92. Imagine a number like 23,923. How do we do this? Do we create a stem with 23,000, so it's just 23? It sort of depends on the range of the data. If my range is from 0 to 10,000, this is really tricky, right? It's hard to know sort of how to split those up. Even software packages don't do a great job with that. So with complicated data sets, the stem and leaf plot is not the way to go.